Hello everyone and welcome back. In this episode we are going to add some geometry to our simulation. In the last one we added the plasticity and now we're preparing everything for a simple one-way rigid fluid coupling, though we need to prepare some things for this. As you can see, the geometry does not collide with the particles, but this is going to change in the next episode. Okay, let us first create a new folder, and I'm going to call this, let's call it shapes. And in here we are creating 3 new classes and files. The first one will be shape.js. Then we have a second one. This will be polygon.js. And then we have a circle.js. And first in the shape.js file, we are creating the shape class. And the shape class will have a constructor. And here we're gonna pass the vertices. And in here, well, of course we need to set the vertices. Then we need to set we can set a color. I'm gonna set it to black. Oh, of course, I don't wanna call this one color, black. I wanna call this color. And then I'm gonna make an if. And here I'm checking the target is a shape so that we can not create a shape class. Okay, I mean, well, we only want to create a polygon and a circle object, not a shape object. And here I'm just saying type error cannot construct abstract instance directly of class shape. All right, and that's everything for the constructor. Then we have some methods. We first have a method is point inside. And here we are checking if a position is just lying inside the shape. And we're gonna return true or false if that's the case. Then we have the method move by. And with that method, we will, move the shape basically. And then we have a draw function where we're gonna draw the shape. All right, and then we have the polygon file. In here, we first need to create the polygon. This will extend from the shape class. Okay, then first we have a constructor again. Here we're gonna pass the vertices. And I'm gonna call the constructor of shape with the vertices. And then we need to calculate the normals in here. So I'm gonna just gonna write a comment and I'll do that later. So let's say calculate normals. Okay, and then we have a draw method. And here we are going to draw our shape. All right. Then we have a circle. And of course we need to create a class again. So class circle extends the shape. Oh, and I need to remove these ones. Here we have a constructor again with a position and a radius. And I'm gonna call the super with an empty array. because we don't have any vertices for the circle, so the area will be just 0. And here I'm gonna set the position to the position and the radius to the radius. All right, and then we have a method called getRadius. And this will just, actually we don't need this method because we can call radius directly. So we're gonna do that if we need it. And yeah, then we have this point inside. We are overriding this method. Okay, and then we have, of course, the move by method. And I think I don't need to override this one. Oh yeah, I need to override it. Do I need to? Yes, I need to override because in our I'm going to do it like this. The circle only has a position and a radius. The shape or the polygon will only have will only have the vertices, not a center position, like in the other tutorial I did about rigid body physics. This will only have the vertices, and if you want to move a shape, we have to move the vertices of the polygon, and if you want to move a circle, we have to move the position. So I'm gonna override this method too. And here I'm just saying this dot position. I just can implement it right away because it's quite simple. And yeah, I'm just gonna add the position, and I'm saying here instead position, I'm gonna say delta because it's an offset. All right. Good. The same thing I can do for the spring. For the spring. For the shape. And here I'm gonna iterate through every vertices we have. So I need to say let I equal to 0, and yeah, I just need to iterate through everything again. Vertices, length I plus plus, and yeah, I forgot this thing here. And then I'm saying this dot vertices position, index position is equal to add this dot vertices and the delta. Okay, nice. Then we have this one, and then we have the polygon. In the polygon, actually, we don't need to do anything. We only need to calculate the normals, and we need to draw our shape. And here, I think we can just, I think we can use, yeah, for drawing our shape, we will use the shape JS file. And here we are iterating through the order of the vertices, and then we have our, well, shape. Yeah, but first let's go to the circle and implement the circle first, because this is the most simple shape we can do, and we are going to use a circle to check if it's if everything is working. So let's first implement the draw method for the circle. And in here, I'm just going to say draw utils stroke point. And I think I need to pass the position here, the radius here, and the color. And that's it. Yeah, then I think for drawing our circle, that's everything we need. But we still need to add our new files to the main HTML. So I'm just going to copy this one 3 times, add the shapes and shape.js file, then the Polygon.js file, and the circle.js file. All right, and now we should be able to create a new shape. And for this, I'm gonna create also a new array, and I'm gonna call this this dot shapes, and I'm gonna push a new circle shape. So this dot shapes dot push, and here I'm creating the circle, and I'm just gonna say new circle. The position will be 400 maybe. Then the radius, I'm gonna say 100, and yeah, that's it. We could pass a color right there, maybe. Yeah, let's pass a color too. This dot color is equal to color, and then we can say I want to push a orange circle, and then I'm gonna push the circle. And of course we need to draw everything, and I think right there, here I have to iterate through all the shapes, and I'm just gonna copy this for loop here. I need to replace the pattern images with this shapes length, and this shapes draw. And if we go now to the browser, don't forget to save and refresh, and we will see we have a small circle. Awesome. So the circle is working now. Then we can do the drawing for the shape or for the vertices. Let's do this. Let's go back and let's go to the shape.js file. In the shape.js file, go to the draw method, and here we need to iterate through all the vertices. So I'm going to copy this for loop here, and here I'm going to call again a draw utils method, and this one will be draw line. And here I'm going to say this dot vertices from the index -1, and I need to start from the first index, because I'm going to draw a line from the last one or from the previous vertice to our current one. Here I'm going to say this dot vertices to the current, and then I have this dot color. So again, we start with with the index from 1. Then I'm going to subtract that, so this will be 0, this will be 1, and I'm going to say, okay, I'm going to draw a line from 0 to 1 from the vertices, and then I have our shape. And I'm going to add a new shape now in the simulation, just to show you something, because we're not done with this drawing, but I want to show you something anyways. So let's create a new polygon. This will be new polygon. I'm just gonna check if we, oh yeah, we overridden the method. So I need to still call the super.draw method to use the draw method from the shape class. All right, and in here I need to pass the vertice array, and in here I'm gonna I'm gonna create a new array, and I'm gonna say the positions will be, let's say 600. Then I'm gonna try and draw a rectangle till 800, 600 in a clockwise fashion though. So I'm just gonna format it a little bit. 600, 800, then 800 to say 800, and then a last line from 800, 800 to 600, 800. Right, and that's our polygon. And of course, I need to push this shape too. So let's push that. This dot shapes dot push, and let's say polygon. There we go. All right, and yeah, I think I'm gonna pass a color here too, and let's say this dot color is equal to color, so that we have a orange color too. And I need to do that right there. Orange. And I think I wanna decrease the height a little bit. Let's say 750. All right. And now we can go back to the browser. Let's see how it looks. Okay, we have a small rectangle. I think I made a small mistake with the vertices positions. 600, 600 must be there. 800, 600 must be there. 800, 750. Let's do it also to 650. Okay. So let's say 700. Maybe that's a little bit better. All right. And then the other one also 700. And this is our rectangle, not finished yet. Just gonna show you which coordinates I used. Yeah, this is my rectangle here. 600, 600, 700, 700. And because we only started from 1 and then we finished, but that means we didn't draw a line from the 0 element to the last one, all right? And that's the reason we still need to draw another line. Luckily, that's just really, really easy. You just have to say from the last index right there. So I'm going to copy this one till the first index. Then we have our last line. And if we now save everything and go back to the browser, we see we have our small rectangle. Awesome. All right. Yeah, and the next step now is we want to move our rectangle by clicking in it and yeah, move it around, also for the circle. And for this, we need to add some logic to find out if our mouse position is actually inside the shape. And for this, I created the isInPointInside method. And we have to implement that for the shape class and for the circle class. Luckily for the circle class, it's quite easy. We can do that right away. In the circle class in the isPointInside, we have to calculate a distance. And this distance, we can get the distance from our current position. We are creating a direction vector from the mouse position and the current position of the circle. It doesn't matter from which of these things you subtract the other one. In this case, it doesn't matter. And then I'm going to call the .length method. And then we have the distance between those positions. And then I can just return if the distance of the mouse position and the circle position is smaller than this .radius, then our point is inside of the circle. That's everything. Yeah, and then we can already use this method. Well, we are going to use that I think a little bit later. Actually, we can implement our dragging around right now, because I'm gonna say here in the polygon, no, in the shape, I'm just gonna return null or false, and we are not supporting the dragging of our polygon right now, but we are implementing everything for the circle just to check everything's working. And then after this one, we will create our movement for the polygon, for the actual shape class. Let's go to the background file and to the class, and in here we need to do some things for our well, object movement, because we need to detect a last mouse position and a selected shape. And yeah, first I need to declare some variables, and the first one will be last mouse pos. I'm gonna set this one to vector 2.0, exactly like the mouse position. All right, and then we have a variable called selected shape. I set that to null. Then I go to the on mouse move, and in here I'm gonna say this dot last mouse move position is equal to this dot mouse position dot copy. And it's really important that you do that before this dot mouse pos, okay? Because then we are grabbing the mouse position from the last frame, and before it's getting its new position, and then we subtract both of these positions, and then we get a well, a offset, a delta position. And then I can say if this dot selected shape, no, if it's not null, then we can say this dot selected shape dot move by. We're calling the method declared in the shape class, and here, and I think I'm just calculating the offset or the delta position, and the delta is just a subtraction from this dot mouse pos with this dot last mouse pos. All right, and then I'm gonna pass delta in here, and then we have our move by function. Yeah, but of course we need to somehow get a selected shape, and we are going to do that with another if statement in the mouse down method. And here I'm saying if button is the 0 button, and I'm going to do these triple equal signs. And here I'm going to say this dot selected shape is this dot simulation dot get shape at. And yes, we need to add this method to the simulation class. And here I'm going to pass the mouse position. Luckily, this method is also quite simple. So let's go to the simulation. And here we are creating a new method. And I'm just going to put that below the create particle emitter. And this one will be called, of course, get shape at a position. And what I'm doing now is quite, well, it's not really, it doesn't has a good performance, because I'm going to iterate through every particle and check if every particle is inside, not the particles, I mean the shapes. I'm going to iterate through every shape, and I'm going to find the shape with the position. I'm going to say, yeah, I'm going to say if the position is in any of those shapes, and if it's so, then we're going to return the shape containing the position. And this one you can, of course, improve if you're using a neighbor search, like in the 2D physics thing, or like in this one, you can map the shape into a neighbor search, like I did in the rigid body tutorial. Then you can find the shape with a much better performance. We're doing something similar when we are checking for particle versus shape collisions. Yeah, it's not really performance. It's not. It's yeah. It doesn't have a good performance. How we are doing that, but it's just a just to show you how we can do it and how we can do a one-way coupling. And yeah, if the position of this method here, if the position of the parameter is inside the shape, we're gonna return the current shape. And I think that's everything we need. We need to return null if there's no shape. And I think that's everything. And now we should be able to move our circle. So, oh, maybe I forgot something. Yeah, I forgot something. If the mouse is up, again in the playground file, in the playground test file, if the mouse button, the button 0, is not hold anymore, it's not holding, well, is released, then I'm going to say this selected shape is null again, and then we can drag this object by holding our mouse button around, and yeah, we can move it in. So let's save everything, refresh the browser, and let's go back. There we go. And now if I click the circle, I should be able to move it, and it works, pretty cool. And if I click anywhere on the circle, I should move it like this. And yeah, it's working. Awesome. And oh yeah, I think you don't see my mouse cursor. I'm gonna fix this, 1 second. Okay, there we go. Now you should see my mouse cursor. There we go. Right, and I can move my circle around. So let's do the same thing for the rectangle or for general polygons. This is a little bit more, well, mathematically involved. What we are going to do is we have to calculate first the normals of the polygon. The normal is calculated by calculating a direction vector from one vertex to the next vertex. Then we have to flip this direction vector, so we get a normal, okay? And then we just need to normalize the normal direction, because the normal direction is perpendicular the other direction, that's why it's called normal. And yeah, we need to normalize this vector then, and then we have our normal. And with this normal then, we can check with a dot product. We are creating a direction vector from every vertex to our mouse position. And then we are using this direction vector with the normal, with a dot product, okay? And this value will be, well, depends, will be negative if we are, well, under this line, okay, below this line, or will be positive when we are outside. Could also be the case if it's that it's going to be flipped, then we have to either multiply it by -1, or we just have to be in mind that it's negative. So it's going to be positive or negative inside if the mouse is inside the polygon. But we will see how we can implement that. All right, let's go first. We need to calculate the normals, and I think I'm going to do that in the Polygon class. So let's go to the Polygon class, and in here I'm going to say, create a new method, calculate normals. And here I'm going to iterate through every vertex. So I think I'm just going to copy again a for loop. There we go. All right. Yeah, and I think This should, I think it should be fine. Okay. Okay, and in the for loop, we are starting again with the first index. Because here again, we need to do the same thing as the last line. Actually, yes, we need to do that. Because we need one vertex and the next vertex, and that's why we need to do that. We need to do something like this. And the first thing I'm going to do now is, as I said, create a vector, a direction vector from our current vertex to the next vertex. Well, actually, I need to call here, I need to do the next vertex because we are subtractively doing a direction vector from our current to the next. And to calculate this direction vector, which is going from the current to the next vector, we need to subtract the next vector with the current one. So that means I have to say this dot vertices with the index +1. And then with our current index. And with this, we are calculating a direction vector which goes in the right direction. All right, and then we have to flip this one, and I'm going to create a new array here, and I'm going to call this normals, which will be an empty array. And I'm going to say this dot normal. So this variable here has nothing to do with this array. Normals is just a magnitude, but actually, yes, it does have something to do. This normal isn't normalized. Yeah, and we're going to do that after we get the normal from our direction vector. I don't even know if we have this method. Yeah, we have this method here, get normal, and we're going to call this one right now. So I have to say direction get normal. Then I'm going to say normal.normalize. And then I'm going to say this dot normals push. Okay, and then we have all the normals from our polygon. And what I'm going to do now is I want to check if it's right. No, I want to check if we have the right normals. And for this, I'm gonna draw the normals. Here we can start from 0 again, because we don't need to do anything with the current and with the next vector. And well, actually, no, that's fine. I'm gonna draw this one at the corner positions, not in the middle of the rectangle. So let me show what I mean. I'm gonna draw the normals on these corner parts, okay? So the first one will be standing out right there. The next one is like this one will be like this, and this one should be like this. Maybe, yeah, depends on how I'm gonna draw this, but I think it's must be like this one. And I'm not gonna draw the normals in the middle, okay, because then we have to calculate the middle position from this side here, and then we need again the two vertices to create a direction vector, and then we have to do this index. We have to start at index 1 again, and so on and so forth. So I'm just gonna do it like this because it's a little bit simpler. But yeah, I have to say for drawing a normal. So first, let's go back to Visual Studio. I'm gonna say let start position is our current, well, start position is our current vertex, okay? and the end position is our current vertex. So basically the start with the normal, but I'm gonna scale the normal a little bit, like with a number of 15. So this is the normals for our current index by 15. And yeah, that's our end position. Then we just need to draw a new line. So draw utils dot draw line. I just want to check if that's the right syntax. Draw line, start, end position, color. Okay. Okay, so start and color is orange. And I'm gonna set the line thickness to the default one. And then I think, did I push this shape already? Okay. Yeah. Let's see, I just gotta check if everything's all right. Ah, yes, I forgot to calculate the normals. So I'm gonna call, or I'm gonna say, this dot, I think actually I can, yeah, I'm gonna say this dot calculate normals, and that's it. All right. And now, oh yeah, I got a small error. I'm gonna check, and I'll be back in a second. Ah yeah, and it seems like I made a small mistake. Here I need to say the index 0 and the length will be -1, I think. Okay, yeah. Yeah, genau. Right? And then we need to calculate the last normal. And yeah, we need to copy everything. And we need to do that for the 0 at the index 0, and then the vertices -1 right here. And now we should get our rectangle with the normals. So let's save everything, go back to the browser, and there we go. This is our shape with the normals. All right. Yeah, now we can implement the isPointInside method. And for this, we have to go to the shape method again. And yeah, let's implement that. First, I'm creating a new variable, and I'm going to call this one isInside, and I'm going to set this to false. Then I have to iterate through all the vertices. So I'm just going to copy this one again. Then I get the current vertex. And the current normal. And now I'm creating the direction vector from the vertex to the position. And yeah, now it's now important how we're going to do that. And it now decides if it's negative if we are inside or positive. So vertex, or let's say vertex vert to point, is the subtraction from yeah, we can now say vertex minus position or position minus vertex. I'm gonna go with position minus vertex. Okay, and then I have to calculate the dot product from the direction vector with the normal. Yeah, of course, this one's Oh, what did I do there? Okay. All right. And the dot product or the result should be greater than 0. Or if it's greater than 0, we know it's not going to be inside. And if it's smaller than 0, then is inside will be true. So we're going to set it to true. But we still have to check every other side. And yeah, that's why we have to iterate for everything, and then we can return is inside. Okay, so let me again go through a little bit through that code. First, we are creating a new direction vector. This is from the vertex to the point, and for this we have to subtract the position, the head position, let's say, from the direction. Okay, so from the target minus the start. Okay, and then we get the direction vector, and this direction vector we have to do a dot product with the normal we calculated earlier. And if we project this direction vector from the normalized normal, it's important to put that it's this one. Well, actually, in this case, it's not going to be important that if it's normalized, because it's going to be positive and negative anyways, but we have to have a normalized normal for pushing our particles out of the object. So we need this one in the next episode. Yeah, for this one, it's the important thing is that it's going to be negative or positive if a particle, or if in our case, if the position is inside, then it's going to be positive or negative. And then we just have to decide what we're going to do. If this value is positive, then we're going to return false. And if it's not, we say is inside is true. And then we still need to iterate through everything to make sure our position is actually really inside of every side. And with this, we should now be able to move our rectangle. I hope at least. Yeah, let's check that out. And seems like I made a small mistake. We have to return true. It's greater. And here, set it to false. Yeah, that's always a small thing. If it's not working, just check if you might multiply something or switch something with -1, and it might happen. Then it's gonna work. But yeah, now we can go to the browser, save and refresh, and by now, well, press my mouse button inside the rectangle, I can move it around, and yeah, it's working. All right, and it's also moving when I'm outside. Okay, well, it's not working. I'll be check the source code and I'll be right back. All right, I found the error. Took me quite some time, and I must say a little bit frustration. And I figured out our dot product is wrong. Oh my god. Yeah, I had a typo right there. This must be a multiplication. God damn it. Alright, but that's happening. Or that happens. Yeah, I hope now it should work. If we go back, to our, where is it, to our is point inside method, I kind of changed it a little bit. Go back and well, I tried a lot of things, so this might be a little bit different now. I recommend check it out. Maybe it's still the same. I unfortunately I don't know anymore. Well, sorry for this. But yeah, if we go now to the browser, and we take our rectangle, and now it's actually working. I also commented the circle. So let's comment that in again. And now we can take our circle and our rectangle, and yeah, it's finally working. All right, what I also did, I added drawing the normals in the middle position. And yeah, that's the code. That's why I didn't want it to, because this was how I did it earlier, and this is how you, this is the code you need to write if you want to draw this one in between the vertices. So I'm just gonna, yeah, I just let it be for you if you wanna look at it. All right, now that we have our both objects here, we can't rotate them. Yeah, note that if you want to rotate the objects, you also need to recalculate the normals. We are only calculating the normals once in the constructor of the polygon. But if you rotate any of those shapes, except the circle of course, if you rotate the rectangle shape or in general a polygon, then you have to recalculate the normals, or you rotate the normals too. Yeah, that's everything. That's also everything for today's episode. In the next one, we are implementing the one-way rigid body fluid coupling, that the particles will be pushed out of the shapes. And yeah, that's our goal for the next one. All right. Yeah, see you in the next one. Have a nice day, and bye-bye.